purpose of today's discussion panel is to enhance your understanding on biofuels and to really get you all to consider the advantages and disadvantages of this unique technology. To start us off today, I would like to welcome Professor Rushil, who has been specializing in the development of hydrogen fuel cells over the last couple of years. So Professor, how exactly was this technology discovered?
So as we all know, for all of you studying Chemistry 3-4, hydrogen fuel cells have primarily been introduced for its sustainability and environmentally friendly prospect that proves an asset to growing problems of nowadays CO2 emissions. However, despite the assumption of its modernity and that sort of stuff, it was actually invented by William Report Grove just to be used as another source of energy so that we stop relying on any one particular source of energy. However, that did not create enough electricity back then, and then it had to be constantly improved upon throughout the years, and therefore it hasn't come into fruition until now, where due to the dire situation we face, we have to rely on them a bit more so that we can create an environmentally friendly future. However, the same problems have arisen in terms of that not enough electricity and efficiency is there, and I'll take you through that with the explanation of the hydrogen fuel cell.
Thank you, Professor. Now moving on to a very important aspect of this topic, how exactly do hydrogen fuel cells work?
So how the hydrogen fuel cell works, chemistry-wise, is that we have one side where there's a continuous supply of reactants from here. So we have a continuous supply of reactants on both sides of hydrogen, and that leads to its own problems, and oxygen on this side. So what happens is hydrogen comes through here and enters this electrode I'm shading right now. And what that does, it reacts, with these the materials in that electrode, and it offloads a electron and also H+, which we'll get into later. And this electron travels up the current and the wires to create a voltage, and this is your voltage reading. And that is simply how the hydrogen fuel cell generates electricity. And obviously, the more hydrogen you have, the more electricity you'll start creating. However, on the other side, for it to maintain a good hydrogen fuel cell and keep working, we have the H+ that we produce from this side. It starts migrating across into this called electrolyte and is used up by the oxygen on this side. So we have the 4H+ and 4E-, it's taken up, so the electrons travel back down here into this electrode, which is known as the cathode, and then out comes water. And now this keeps happening, and then we can generate this. Now, because this is not as powerful or as significant as a coal plant, for example, we don't get as much electricity coming into this voltage reading, and therefore not as much electricity can be used and outsourced in the transport industry, such as the planes and the ships and the cars.
Once again, thank you so much, Professor, for sharing your knowledge on this topic. I would now like to introduce Dr. Ananya, who will talk to us all about the real-world applications of this technology. Good morning, Dr. Ananya. What types of transport methods use hydrogen fuel cells?
Hydrogen fuel cells can be used in various methods of transportation, from unmanned aerial vehicles to huge submarines. Out here in California, we have the largest number of hydrogen fuel cell vehicles and one of the largest hydrogen refueling stations in the world. The state has constantly encouraged the use of hydrogen fuel cell vehicles since the past 20 years. The price of the hydrogen is per kilogram approximately $13, which is fairly affordable for the majority of the population.
Currently, where do we see this, and what does the future of cars look like?
Hydrogen fuel cells are being rolled out across numerous transport verticals, including trains, trucks, and buses. These industries are all pushing to reduce their carbon impact. It is scientifically stated that hydrogen fuel cells can generate more power when pulling heavier loads uphill than an equivalent sized lithium-ion battery and offer a great range. Companies like Hyundai is investing heavily in hydrogen, planning to put 1,600 hydrogen trucks on Swiss roads by 2025 and set to launch similar projects in other European countries.
Is this similar to other methods of transport?
The technology has a way to go, particularly in obtaining and transporting hydrogen. It's years away from mainstream adoption, especially in cars. Hydrogen fuel cells are not a threat to electric vehicles, and I don't believe we'll ever see adoption overtake electric cars. However, hydrogen fuel cells will remain relevant, particularly in long-distance transport, such as freight trucks and trains. Whatever your view, governments are heavily invested in hydrogen fuel cells. This provides an opportunity to accelerate innovation, and we can expect to see a greater range of improved product offerings, both in development and market.
Thank you, Dr. Ananya. Now, today's discussion panel is about exploring all aspects of hydrogen fuel cells. That means the good and the bad. I would now like to introduce Roy, who is the member of the general public and is not in favour of this new technology. Let's find out why.
Thanks, Sam. While it's good that we're considering fossil fuel alternatives in the transport industry, I just don't think that hydrogen is a viable choice. Even though hydrogen may well be a competitive biofuel for economic and fuel prices are high, there are significant fixed costs associated with hydrogen price. For example, the hydrogen powered Honda Nexo costs almost $60,000, which is about $86,000, whereas the otherwise comparable petrol-powered Honda Tucson costs only $40,000, less than half the price.
Thanks, Sambi. While the price of hydrogen vehicles and fuel are currently more expensive than electric and petrol, it's still a relatively new concept and isn't being developed by many companies. This means that mass production is unable to fully occur, therefore explaining the high prices. As hydrogen becomes produced more and more, the prices can be expected to lower as more efficient production can occur.
Per 100 k's, we estimate that bike costs was $16 for so it's not like hydrogen is significantly better than moreover, a regular city bus might cost around $450,000, but a comparable hydrogen-powered bus will cost $100,000. In other industries, in other modes of transport, the problem is only accessible. The wages are longer, which means that you have more food sales and higher fixed costs, and the possibility that you might have to impede on your cargo space in your ship or plane in order to make room for those extra fuel cells.
When it comes to trucks and buses, hydrogen fuel cells are far superior to electric batteries. Hydrogen fuel cells can be anywhere from 6 to 50 times smaller than electric batteries. This means that electric vehicles are heavier, thus require more energy to move, and for the case of trucks, the electric trucks will have reduced room to carry cargo as the battery takes up space. For the environmental factor, currently yes, steam reforming for methane is the main method. However, there are other options which we can use. We could actually capture methane that would have been released by decomposing organic matter and use that methane in steam reforming in a process called anaerobic digestion. This will not only stop the methane being released into the ozone, but also produce hydrogen. An alternative method is electrolysis, where we apply electricity to water and create hydrogen gas and oxygen. If electricity is made from renewable resources, then this is a clean process. So this is how we could actually produce cheap and clean hydrogen fuel.
There's also the issue of whether this supposedly clean fuel actually calculates. Hydrogen can power zero-emission electromobiles after it's formulated, but about 95% of hydrogen fuel is made through an energy-intensive steam reforming process, which relies on methane, the worst of the top-level gases. From the environmental perspective, this makes it very difficult to support the so-called grey hydrogen, which ultimately derives from the burning of fossil fuels. Technological advancements might make green hydrogen a viable solution in the future, but it's currently not price competitive with grey hydrogen, and it's not being manufactured at the necessary scale to be a full solution for the transport sector.